Sets might look simple, just curly braces and some elements inside, but they are the building blocks of everything that we are going to learn in computer science. Sets are not just some abstract structures in math, but they are the foundation of everything in theoretical computer science, because when we want to talk about probability, when we want to talk about algorithms or logic, what we care about are inputs, states, graphs, relations, even languages, and for all of them, we need sets to help us to define them. So all of the questions in probability and algorithms are about what is in the set, what is not in the set. It is the reason that if you learn about sets, you actually learn about all the foundation that you need for computer science and discrete math. And sets are not only important in theoretical aspect, they are also useful in practice and programming, because set can be seen as a data structure. So it is the reason that in this video, we are going to learn about sets. We are going to learn what sets are, how we can show them, how we can see how many elements are there, or find the size or cardinality of a set. We are going to learn about empty set and universe, and we are going to learn about well-known sets in mathematics, like natural numbers, integers, and so on. So what a set is and how we can show it. We can show a set by curly braces and elements inside, separating them with comma. Actually, we can define a set as collection of things. These things don't really have to be of the same type, like they don't need to be all letters or numbers. But most of the time, we prefer to work with the sets such that all the elements are of the same type, so we can easily define a universe. We are going to learn about universe in just a minute. There are two important things about a set. One of them is that it is like a shopping bag. When you put things inside, the order doesn't matter. I don't really care about putting orange first or apples first. The other thing is that in sets, duplicates don't matter, which means that if I have a repeated item, I don't care. I only count it once because unique elements matter. I think it is a good time to talk about size or cardinality of a set. When we are going to count the number of elements of the set, we only care about unique elements. We show size of a set with this notation, and then we only count the unique elements. So the size of the set A containing 2, 4, 4, 6 is 3 because we don't count 4 twice. Now that we learn about set and size of a set, we can talk about empty set and universe. Empty set is basically a set that doesn't contain any element. So the cardinality of an empty set is 0. We can show empty set by curly braces with nothing inside. But empty set is important enough to have its own notation as well. We show empty set with this notation as well. Sometimes we define a universe that actually helps us to see what are the things that we are working on right now. For example, when I tell you the universe is 1, 2, 3, 4, 5, then it means that my focus is only on the numbers 1, 2, 3, 4, 5, and I don't care about any other numbers or elements or objects or anything. There are two different ways to define a set. One of them is roster style, the other one is set builder notation. In roster style, we only list the elements, like A is equal to 2, 4, 6, 8. In set builder notation, I don't list the elements, but I define a property about these elements. Like the set A is equal to X, such that X is an even number, and 2 is a smaller equal to X, and X is smaller equal to 8. Note that A again contains 2, 4, 6, 8, because these are the only even numbers between 2 and 8 inclusive. There are some well-known sets in mathematics, and mathematicians use some specific symbols or letters to show them. Like we show natural numbers by n, and it contains 0, 1, 2, and so on. Z is the notation that we use for integers. They contain all the negative and positive whole numbers. R is the set of real numbers. Q is the set of rational numbers. Rational numbers are the numbers that we can write as a fraction such that both parts of the fraction are integers and denominator cannot be 0. Something like 2 over 5 is a rational number. Irrational numbers are any real numbers that are not rational. So if we want to use set Wheeler notation to define irrational numbers, we can say x such that x is in R but x is not in Q. In this video, we learned about what a set is, how we can show it, how we can decide about the size of a set, what is empty set, what is universe, and how we can show well-known sets in mathematics. In the next video, I'm going to talk about elements of a set, subsets, power set, and equality between sets. See you in the next video.